Okay, our objective today is to finish up talking about proportions and cross products, and then talk about an introduction to geometry. I think today's lesson is really interesting. Does anyone in here really like geometry, or know that you might like geometry? Okay, little break from algebra, it's kind of nice. So also one more reminder, you have one more quiz before report cards that'll be up through 6-6. Let's go over the warm-up first, and then we'll go over the homework. Okay, so Annalise, we'll start with you on number 1 on the warm-up. Good. Sean, number 2. Say that again. Good job. Briar, number 3. Page 87. Briar, what were you supposed to be doing while we were talking about weekends? Oh, you worked backwards. Okay. Okay. Zach, number 3. Good. 1.2. Emma M, number 4. Good job. Number 5, Jeremy. Nope. Close, though. Donatus, number 5. Good. 22. Alyssa, number 6. Good job. Oh. Okay, number 7, Emma H. Good. 60 cents. Doug, number 8. Good. 5.6 or 28 over 5. Adam. Should be 1. Number 4. So when you have a proportion and an equal sign between, use cross products. Okay. So 4 times y is 4y. 5 times 0.8 is 4. And then divide both sides by 4. You might have multiplied wrong. Okay. Should be 4. Anyone else? Questions? Jeremy? Number 5, how would you get 32.5? Is that what you just said? The answer is 22, not 22.5. Okay, no. That's why. You got to use cross products. So let's multiply these first. You have 36, and then in parentheses, x plus 5. Did you not set it up that way? Equals 54 times 18 is 972. Did you watch the video from Friday? Okay, you probably didn't because you were finishing your test Friday, so you need to watch that video. Okay? When did we use cross products? Who can remind us? When do we use cross products? Sean? Yep. Also, there's something else I want you to say. You're right, when else do we use cross products? Something very specific we talked about Friday. Emma H? Yeah. When else? Sean? Good. Only during an equation. So what 2 things are always set equal to use cross products? Doug? They begin with an R. What are they called? Alyssa? Nope. Justin? Good. Ratios. Okay. When you have ratios set equal to each other, you have an equal sign between them, always use cross products. One of the most common mistakes is whenever people see a multiplication in between, they'll try to use cross products. What do you do if this was a multiplication symbol? What do you do, Mary? Good. You can cross simplify and then multiply across the top, across the bottom. Very different things. Don't get confused with that. When there's an equal sign, use cross products. Charles. Yep. Yeah, you can do that. Yeah, Charles and anyone else, you actually can even divide both sides by 36 first and then subtract from 5. So you could also get rid of this first by dividing. There's a lot of ways to solve this. The biggest thing I want you to know is how to solve using cross products, that first step. What you do after that is up to you. Doug? Number 6? Okay, so did you do 75 and then in parentheses 15 minus x equals 45 times 15 is 675. Okay, and then did you distribute the 75 through? Okay, what did you get after you distributed the 770? Okay. Okay, and then did you subtract 1125 from both sides? That's why. You're going to always do the opposite. Okay? Anyone else on the warm-up before we go over homework? You okay with the rest of it, Doug? Okay, let's go over practice 6.2. Okay, starting with number 10. Okay, Alyssa, what did you get for 10? Good. Mary, number 11. Good. Number 12, Emma M. Good. Emma H, 13. Good. Charles, 14. Good. Annalise, 15. Good. Sean, 22. I didn't skip any, right, guys? Okay, just making sure. Sorry, say that again, Sean, 22? Yes, 6 notebooks. I'm going to put NB. 23, Adam. 10 what? Good. 24, Matt. Good. 5 paper towel rolls. Justin, 25. Good. 20 hours. Okay, 26, we have an A, B, and a C. So starting with A, Doug, what did you get? $2.50. Annalise, B. Good. $5.25. Zach, letter C. $9 and what? Should be $9.60. Mary. What number? Sorry. Okay, so tell me what your proportion was before I explain it. 1.5 over 3 equals x over... Okay, that works. Equals... Well, you said 1.5 over 3 equals x over 5. Okay, that works. Okay, after you multiply it, so you have 3x equals what? What'd you put for 5 times 1.5? Yeah, I don't know either. It's 2.5. You have your proportions set up right. I would just say multiply again, divide, use your calculator. You probably just made a silly mistake with dividing because the hard part you did right. You okay, Mary? You okay? Sean? What did you do then if you didn't use a variable? You did. You did. Anyone else before we go over 6.3? Matt? Yep. Okay, so let me go through this with you. So for 26C, you had to find the unit rate. In other words, you had to find how much each one cost. So starting with apples, Matt, what did you put for the cost of the apples? Good, so the apples are $3.75. What did you put for the cost of the bananas? Good. What did you put for the cost of the cantaloupe? Good. Okay, you're still good. What did you put for the cost of the peaches? That's where you messed up. The peaches are $1.80. What's your proportion for the peaches? Okay, so anyways, if you did, peaches is 1 over 0.90 equals 2 over x. So peaches is $1.80. What did you put for cherries? It should be $1.80. So you messed up on cherries and peaches. So you need to find how much each of them cost and then add all of them up. You okay? Okay. Jeremy? Sure? Okay. Anyone else on 6.2? Annalise? Okay, I just went over that. Did you listen to what we just went over? I know we just went through all of them though. Did you follow us as we went over them? Okay, that's all. Okay, ready? One more time, Annalise. Peaches and cherries are each $1.80. Okay, and if you add all those up that Matt and I went through, that's on the board, you do get $9.60. Just be careful, guys, for everyone. Take your time when you're finding how much each one costs, because after that, all you're doing is adding all them up. Okay, anyone else on 6.2? Okay, 6.3. Annalise, you okay with the cherries? Okay, practice 6.3. Let me just read the first couple. Number 1 is yes. 2 is yes. 15 is 30. 16 is 112. Make sure you guys are checking. 17 is 270. Mary, you checking yours? 18 is 4. Okay, Zach, we'll go to you for 19. Good. 19 is 47. Sean, number 20. Good. Annalise, 21. Awesome. Charles, 22. Great job. 23, Mary. Good. Adam, 24. Nope. Try 25, Adam. What'd you put for 25? Okay, what'd you put for 26? Okay, Adam, you got to make sure you do your homework correctly. Okay? You don't have 26 either? Okay, Emma, 24? Okay, unless I messed up. 24, Charles? Negative 36? 20, I'll go over it. 25, Alyssa? Good. 26, Donatus? Good. 25. Jeremy, 27. Say that again, Jeremy. No. You defined how many were defect. Oh, never mind. Your number's just wrong. Matt, what did you get for 27? Yep. So, yep, 300 out of the 12,000 are defective. Okay, 28A, I'll let someone talk through this. Charles, how do you set it up? Tell us that first. Okay, how did you know to set it up like that, Charles? Because a lot of people were confused on this, so can you explain? Good. Yep. So after you combine like terms, we get 9x equals 46,260. So we know then the answer here, you had to find how many first class stamps there were and how many postcard stamps there were. So Charles, what did you get for first class stamps? Good. And how about postcard stamps? Good. If we add these numbers up, we get the total amount of stamps, which is 46,260. Yeah, you could do that too. So basically, you're given a ratio in this problem because you know that for 7 first class stamps, 2 postcard stamps are sold. But knowing that does not mean that you use a proportion to set that up. You have to use an equation, because first at least, because you need to figure out, okay, well, 7 times what plus 2 times what gives us the total. Once you find what x is, then you just take your x value, which I think I wrote that down. X is 5,140. You multiply that by 7 to get to first class stamps. You multiply it by 2 to get to the postcard stamps. So you're just solving an equation, taking your x, plugging it back in. Remember, 7x represented first class stamps, 2x represented postcard stamps. Those of you that asked me about A, does that make sense or are you still confused? Most of you are shaking your head yes. Annalise? Yep. Yep. Because that's the rate, that's the ratio. It's more like the rate. You don't know anything else about the total. You just know the ratio of first class to postcard. I agree, this problem does make you think, 'cause it is a little bit different. Sean, are you okay with setting this up? Okay. Okay. Part B. What did we get for part B? I'll let someone else answer that. Emma H., what'd you get? Awesome. Good job. You can simplify it. I simplified it on mine, but I did definitely want the initial ratio of what Emma H. gave us. So who did simplify and would like to give us the simplified answer? Charles? Good. 259 over 46 is the simplified answer. So either one of those is fine. Again, I want the original one. It didn't say to simplify completely here, but like I told you Friday, always simplify ratios. Okay, letter C. Zach? Good. No, they are not equivalent at all. You have to multiply by different numbers, or if you simplify both of them completely, they are not the same at all. Okay. Yeah, one is 7 over 2 and the other one is 259 over 46. Nothing alike. Okay. Questions? Annalise? 17, you got 70? Okay, after you do cross products, did you get 0.4x equals 108? Okay, then do 108 divided by 0.4. You get 270. Okay, Emma M? Sure. 24. Okay, let me just ask you if you got this for your first step. After you do cross products, you should have 980 equals 260 minus 20x. Okay, so let me move this then. So Emma, after you have 980 equals 260 minus 20x, you want to subtract 260 from both sides? Oh, okay. So from there, you get 720 equals negative 20x. Divide by negative 20, you get negative 36. You okay? Okay. Annalise? Yeah, that's a simplified answer. Yep. Anyone else? Questions, repeats? Okay, thumbs up, thumbs middle, thumbs down on proportions. I know that one word problem is hard, but basically on everything else. Okay, it's pretty easy still. Okay, who can remind us one more time, when do you use cross products before we talk about geometry? When do we use cross products? Emma M. Good. When you have two ratios equal to each other, which you could also call that an equation with ratios. Doug, question? Okay. All right. I need everyone to open up your notes to page 9. Okay, so we are going to talk about some basic geometry concepts today. I wanted to get through 2 lessons, but I don't think we're going to. That's okay. I just want to at least introduce it. This is something that you need to know in this pre-algebra book, but we won't truly get into geometry until chapter 10, which I think you'll like chapter 10. There's a lot of formulas you learn. There's a lot of ways of learning how and why geometry works. I usually teach geometry, just not this year, so there's a lot of things that I know that I need to teach you because you'll see it when you do take geometry for a full year, which you'll have in 2 years. So today, just the easy stuff. Just in general, what are the basic concepts? Donatus? Oh, did you? Yeah, tangent is cool. Good for you. Well, then you might know a lot of this, especially when we get to chapter 10. All right, so starting with, there's a big box on page 9 that just says, Word notation diagram. So this is really easy. Are you ready for this? Point. Wow, what's a point? Well, you could use the notation point A. This is what a point looks like, okay? Here's a point. Now I'm serious. This is part of this class. And you have to label it. Real difficult. Charles. Well, it's not this easy. You do a lot of proofs. It's not this easy. These are just, Charles, when I say basic, I mean basic. Very basic. Well, we're not done yet. Okay, we're not done yet. Okay. Okay, next one. What's a line? Who can just tell me? Jeremy, what's a line? Okay. Good, like JK, just kidding. Going forever, going on in both directions. So I used BC. JK would be much more exciting. Okay, the line, I should say, has arrows on both ends. It extends forever, okay, and has arrows on both sides. So it keeps going forever on both sides. So if you draw a picture of a line, you still have to have points. Okay, we already talked about what a point is. Here's a point. Here's a point. I know. Wow, amazing. BC. Arrows on both ends. A line goes on forever, infinity in both directions. Okay, what's a plane? No, don't tell me it's an airplane. What's a plane? Mary? It's a flat surface that extends forever. The notation. A plane is typically identified and labeled as using a capital letter or as using 3 capital letters. So I put it on here as 1 capital letter for now because your book uses 1 letter. The geometry book uses 3. So let me put the word plane in front of it. You can put this as 2 different options. You will also sometimes see like plane M, okay? When you get to geometry, they will also tell you you could also name a plane using 3 capital letters that are not on the same line, which means are not collinear. Collinear means they're on the same line, so Mary was going to tell us that. So I'm not going to go that far because your book doesn't go into that much detail. But remember, there's another way to name a plane. It's a flat surface that goes on forever, kind of like 1 solid piece of paper, just 1 flat piece of paper, but it goes on forever. Donatus. Yeah, you name your plane Joe. Yep. That's funny because that's Mr. Warnock's first name. It's funny you said that. Emma M. No. Very different, but good question. Mary. The whole semester? A lot of it. Okay. All right. That's funny. Hold on. Okay, let's hold that thought. Okay, next example. Okay, we need to name 3 points here. So, Briar, give us 1 point. Good. J is a point. Zach, give us another point on this picture. What'd you say? No, P is not a point. We already have J. Which one? K, there we go. Okay, Sean, another point. Good, L. There are 3 points on this diagram. Look, J, K, and L. P is not a point. Okay, all joking aside, I know point's easy, but please make sure there's a point next to the letter, okay? Okay, give me a line and tell me what the notation, well, actually, just give me a line. We'll start with that. Emma H. Good, J, L. Anyone know what has to go above a line? Or remember, Justin? Good, so put arrows and going in both directions. JL is a line, put the line above it, arrows going in both directions, indicates it goes on forever. Okay, what's another line, Alyssa? Good, KL. Alyssa, what goes above it? Good, arrows in both directions. Annalise? Nope, nope. Okay, what's a plane? So what's a plane in this figure? Adam? Good. P. So I'm going to draw it, okay, and put a P here. But notation-wise, it's plane P. Now, anyone want to try naming it using 3 letters? Charles? Good. Plane, J, K, L. Those are 3 points that are not in a straight line. In other words, they are not collinear. Okay, so either with 1 letter, which is not the point, or 3 points that are not in the same line. Either way is fine. Emma. Jeremy, you with me? So if K was here, you cannot use those 3 points to name the plane. You would have to use this. Very good question. Sean? Are not in a straight line, correct. So as Emma said, it has to be there. That doesn't matter, because these 2 are in the same line. Charles? No, it has to be 3 letters. No, it has to be 3 letters. 3 that are not on the same line. Okay, are these questions or comments, guys? Okay, Donatus? That doesn't matter. You can still name a plane with 3 letters that are not on the same line. Oh, I'm sorry. Then you'd have to use like AB, AC, AD. Yeah, because we're not making up letters. Good question. That does not happen very often. Annalise, what was your question? Okay. All right, so next part. Anyone know what a congruent segment is? What's a congruent segment? Emma H? Yep, you guessed correctly. Congruent segments, okay, have equal lengths. Congruent segments have equal lengths. So I'm going to draw 2 segments up here. And then I need to explain a couple more things to you guys. So here are the congruent segments, AB and CD. The symbol for congruent is an equal sign with a squiggle line above it. It is weird. So this symbol right here, an equal sign with a squiggle line above it, means congruent. Okay. The line above these capital letters means a segment. There's not arrows, so that means it's there, it stops. Okay, it's just a segment. AB, this is notation for segment. CD, notation for segment. If I'm showing you that segments are congruent, you use something called a tick mark and draw on them. This tells you in geometry that this is congruent to this. So if you use a tick mark, that tells you this is congruent to this. Annalise? You can put it, but typically you just see it as a line. Not a line. I call it a line, but a line with no arrows, I guess I could say. You can put the dots, but in geometry you never use the dots. You just put the line with no arrows. Okay, next one. Congruent angles. Oh, who would have guessed? Angles that have the same measures. So congruent angles are angles that have the same measure. And I'll explain my picture to you in a second. Alyssa. Oh, so you've seen a lot of this. Oh, good. That doesn't always happen. Adam? Yeah, but I'd rather you not. Use the variable. Okay. Congruent angle. So here's an angle and here's an angle. One way to write an angle is using the angle symbol in front of a letter. To say that they're the same, use the symbol for congruent, equal sign, with a squiggle above it. Now, if you have two quadrilaterals, so I have a quadrilateral here, quadrilateral here. If you're using a figure and you want to show that angles are congruent, you use this curvy line to say this angle is congruent to this angle. You use this curvy line to say this angle is congruent to this angle. Have you guys seen this before? Okay. Emma, have you? I mean, typically, I'm just showing you a quick example. Typically, they'll be labeled like A, B, C, D, E, F, G, H. I'm just not getting into all those details right now. But yes, if we get more specific here, if it's a figure, it's always going to be labeled. It has to have a name. Any other questions on congruent? Okay, let's flip over to segments, rays, and angles. Told you guys this was easy. Okay. Line segment. So now we're going to talk about a segment in more detail. So a line segment or length of a line. So a segment, you could have a line above it, okay, or we could have nothing above it. Either way, it represents a segment. Okay, I like to put the line above it. If you do put the two dots above it, that's fine. Okay, but I prefer that you just put that segment above it and you don't put dots. If you do put this, that works, okay? But typically, this is the one that you'll see. Doug? If we're learning in class, yep. Okay, so a segment, we're going to draw one here. A, B. A segment does not go on forever. It has endpoints. So there's three ways that you could see it using the notation. Again, typically the one I circled is the one that you'll see. Okay, what's a ray? What's a ray? Ooh, a lot of you. Briar, what's a ray? Good job. So a ray, one end of it has an endpoint, the other end goes on forever. So you could see the notation like that with a point on one end, an arrow on another. Or you could see it with nothing on one end and an arrow on another. C, D, I'm going to draw it. Here's our ray. Anyone know what we use rays for? What's one big thing in geometry that you use a ray for? Charles, do you know? Okay. Oh, line is, because a line goes on forever in both directions. Well, I know. Yeah. So I guess if you think of it that way, forever is forever, then they're equivalent. But still, the line goes on forever in both directions. I mean, Charles, I understand what you're saying. But if you think of which one's getting to forever faster, it's the line, because it's going in both directions. If that even is possible. Yeah, I don't know. Okay. So what in geometry do we use a ray for? Matt? No, that's what we use segments for, but I like the way you're thinking. What in geometry do we use a ray or rays for? Alyssa? Awesome. Why? You're not sure? Anyone know why? Very good. Charles, why? Okay, is that your reason? Okay, so basically, let me show you guys. So I'm going to draw the picture first. So here's the next one's angle. So here's what an angle looks like. So here's, yep, acute, obtuse, straight, right. We're going to talk about that tomorrow. So A, B, C. Here's our angle. This is the vertex. Like Alyssa told us about the rays. Here's a ray. Here's a ray. The point where they meet is always called the vertex. An angle goes on forever in these directions, but of course this does not. It just stays there. So we could still argue what goes faster, a line, a ray, or an angle. They're both going to go on forever. So I can't really answer that. Now, naming an angle is a little tricky. Anyone know one way to name this angle? There's 4 ways. Doug, what's one way? Okay, so angle A, B, C. What's another way to name this angle? There's 3 more ways. Briar. Okay, good. Angle CBA. I forgot to count those ones. There's more than 4 then. You're right. Charles? No. Why not? Why does CAB not work? Mary? The vertex always has to be in the middle. For CAB to work, the angle would have to look like this. Get it? Okay, what's another way to name this angle? Emma H. No, that is right. Angle B. Okay, so now there's actually 3 more ways. There's 6, not 4. I forgot about Breyer's way. Adam. Nope. You have to use 3 points to name an angle unless you just use the vertex. No. Okay, so you probably have never seen this before. Okay, so these are all right. Now, if someone asks you to find the measurement of an angle, you have to put a little m in front of it, which indicates this is the measure of CBA. This is the measurement of B. So these 3 ways, I guess you wouldn't say are completely different, but it's the notation you use if someone's asking you, what is the measurement of this angle? If they're just asking you to name an angle, you use these. If you're finding the value or measurement of an angle, you have to put that little m in front. You'll use this a lot in geometry, which indicates you're finding the measurement of something. Questions on that one? Okay. Let's skip the example for a second because I want to give you guys the last couple definitions, and then we'll come back to the examples. Annalise? Yeah, so it'd be like m of angle ABC equals 12 degrees. Okay, skip that example for now. Let's go to, because the examples are easy. So, triangle. Notation for a triangle. You have a little triangle in front, capital letters ABC. So if you see a triangle, notation is you have a little triangle in front, and then capital letters ABC. So here's our triangle, A, B, C. How many vertices are in a triangle? Emma H? Good. There's 3 vertices in a triangle. A, B, C. Yep. Doug, because it's a question. Go ahead. No, it doesn't have to be filled in. I just was having fun, decided to color it in. No, it can be open. Okay, next one. How many sides does a quadrilateral have? Justin? Good. Quadrilateral has 4 sides. So if you want to write that down, you can. If you know that, you don't need to. Quadrilateral is made up of 4 segments that intersect only at their endpoint. Notation for a quadrilateral is either, which I don't like this way, is writing out the word quadrilateral or drawing a quadrilateral in front. If we draw what PQRS looks like, PQRS, it's very important that you label it in the order they give you the name, PQRS. Or you could have done PQRS. Or you could have done PQRS. I could keep pointing to names. They have to go clockwise clockwise or counterclockwise, depending on, yes, in one direction. Do not jump around and go PQRS. Don't do that. It has to go in one direction or the other. That's a big common mistake in geometry. Pretty easy, right? Questions on what I just went over? Because I'm not going to have time for those last 2 examples. Okay, so I want you guys to do the example above that chart and the example below for homework. Do you see those 2 sections of examples we skipped? Give me a head nod. Does everyone see those? Above, okay, if whoever said no. This example, okay, and then the example right here, below that. So on my paper, which is the same as yours, this example, 2 examples on that page. John, you look confused here, okay? Okay. And then page 2 86 in your book, numbers 1 to 10. I knew you guys would. It's Monday. I figured you need a smiley face. That was so examples on page 10 of your notes and page 286 in your book, numbers 1 to 10. What's wrong? Well, don't forget, you have the online book too. Doug? Doug, I don't know what you're asking. You is what just a line? What? I don't know. What are you looking at? The triangle? Oh, yes. Guys, actually that goes, this triangle, check to see if this triangle is cut off on your notes. Should be X, Y, Z. Is that what you meant? Okay, so just add in the Z. The Z should be there. Everyone check, guys. Jeremy, check, please. Page 10 of your notes. Make sure, I'm assuming all of your triangles are cut off. Should be X, Y, Z. It probably is. Page 10 of your notes. If one person's is, I'm sure they all are. Annalise? You can write any of them. Well, no, you can write them anyway, but you have to write down what all three angles are. So you could do like angle Y, or you could do angle X, Y, Z. Those mean the same thing. But there's three angles. You have to write down what all three of them are, but you can write it either way.
Which one would the vertex be?
They're all vertices. You have to name this one, and this one. Okay? Just like that example we did. No. Angle Z is the same thing as angle XZY. Z has to be in the middle. Okay. Anyone else? Everyone has the homework? All right, let's get packed up.